Hey Victoria, I'm going to give you a couple problems here just talk through it with a little bit more practice with radicals. So you're right, the ones that have the variables under the radical can be a little bit more confusing. So let's just do a couple problems here. So if we start with kind of a more basic one, and we have so let's say we have something like this, like 16 times x squared times y. We know that we can take out a 4 because 16 is a perfect square. So that's going to go outside the radical. Well, x squared is also a perfect square because x squared, the way we get that, remember there's little imaginary ones here. So x squared is just 2x's multiplied by each other. So just like the perfect square here, I'm going to take out 1x outside the radical. And then I have this y left over. I can't do anything with that. I can't simplify it because it's not a perfect square. It's just by itself. So that y is going to have to stay inside the radical. And that would be my final answer with that. The problem that you sent me, it was number 10 on your worksheet. X7 times y to the 4th. So there's kind of a trick here with doing these problems. So if I simplify the square root of 289, that actually works out to be a perfect square. So the square root of 289 is 17. So I'm going to take out that 17 outside of the house. And then the trick with the exponents, what you want to do is take the exponent. So we have x to the 7th. So I want to take this exponent, 7, and I'm going to divide it by 2. So if I take 7 divided by 2, in my calculator, it would be 3.5, or I know 2 goes into 7 3 times with 1 left over. So what that tells me is I'm going to take out 3 x's outside the radical. So that's going to be my new exponent, is x cubed, and I'm going to be left with, let me leave myself a little space here, I'm going to be left with 1x left over. And another way to check it, if we go the other way, it might make more sense. So if I say x cubed, if I'm going to square that, that would be x to the 6th, and then if I multiply that times the 1x that's inside the radical, that gets me back to what I started with, which was x to the 7th. So to check your work, you can square the exponent, or double the exponent, and then add 1 to whatever's left in the radical, and they should add up to the 7 that we started with, which they do. Okay, and then let's do the y. So on this one, I have y to the 4th. So I'm just going to look at my 4 and say 4 divided by 2 is 2 with nothing left over. So I have y squared on the outside. So that's my whole answer. 17x cubed, y squared, square root x. So let's just make up another one here. So let's say we have the square root of 20, x to the 5th, y to the 3rd, z squared. Okay, so you probably have recognized by now that anytime I have an odd number that's an exponent, I'm going to have something left over that's inside the radical. When I have an even number exponent, since that's evenly divisible by 2, I won't have any of that variable left inside the radical. So let's start with the number first. So let's start with 20. And we know that's 4 times 5. So I can take out the square root of 4, which is 2. And I'm going to go ahead and put my radical sign here. So I have 2, and then I'm left with my 5. My number 5 is still inside the radical. And then we'll go on to the x's. So with the x's, I have x to the 5th. And so if I take 5 divided by 2, I know I'm going to have 2 with 1 left over, so 2.5. So I'm going to get x squared, and I have 1x left over. Another way of looking at this is x to the 5th. I can say that's like x times x times x times x times x. That's x to the 5th. And so what I'm really doing is I'm looking for pairs of x's. So I have 2 pairs of x's, so that's how I get x squared, and I have 1x left over. And then let's go do our y's. So I have y cubed. So I could say 3 divided by 2, that's going to be 1.5 if I want to do it that way. Or I can say that's y times y times y. So I have 1y on the outside. And I'm going to end up with 1y left over. So that's my y cubed. And then the last one, z, I didn't leave myself much room for z, but z squared, 2 divided by 2 is just 1, so I get 1z on the outside. So my final answer, I should get 2x squared yz times the square root of 5xy. All right, let's try one more. Let's say, okay, so why don't you pause this and try it yourself and see what happens. Okay, so first thing I'm going to do, I'm going to simplify the number. So I know 9's a perfect square. So here, I'll go ahead and draw my radical first. So I'm going to take out a 3, and I'm left with the 3 inside. And then I'm going to do my x to the 9th. So if I say 9 divided by 2, that's 4.5. So 4 with 1 left over. So x to the 9th becomes x to the 4th and 1 left over. And then y to the 7th. So that becomes y cubed with 1y left over. And lastly, we have z to the 6th. So 6 divided by 2 is just 3 with nothing left over. So I have z cubed. So again, you want to simplify your numbers just like you do without the variables in the problem. And then with the variables, look at the exponent. And if it's an odd exponent, like 9 and 7 in this problem, you know you're going to end up with one of those variables left here under the radical. If it's an even exponent, like z to the 6th, that's going to simplify perfectly. So I'll just have half of that exponent. 6 divided by 2 is 3, and that's how I get z cubed on the outside of the radical. So I hope that helps, and we can go over more of this next week. I'll talk to you later, and good luck on your test.